Okay, so we talked in class about this problem, providing us with a challenge because we're going to have to use the conservation of momentum and the conservation of kinetic energy, which we are allowed to do because this is an elastic collision. Two of them bounce off each other perfectly. No loss in energy, of kinetic energy. So we're going to use both, and we're going to get two unknowns, and we're going to have to come up with two equations. So we'll start with momentum. We're going to have the initial momentum is going to be m1 v1 initial. Now I'm referring to 1 is ball 1, of course, and 2 is ball 2, which, by the way, is stationary. So in this case, is going to be 0 for ball 2, m2 v1, v2 0 is going to be 0 because it's stationary, equals the mass of ball 1 times ball 1's final velocity plus the mass of ball 2 times ball 2's final velocity. Fill in some numbers. So I'm going to have 2 kilograms times 3.98 meters per second is equal to 2 times v1 final plus 7.1 kilograms times v2 final. Now, that leaves me with, let's see, 2 times 3.98. Is it 8.9 or 9.8? Let's check that, shall we? 9.8, okay, good. Alright, so I have 7.96 equals 2 v1 final plus 7.1 times v2 final. And that gives us an equation with two unknowns. So I can't do much. So I'm going to go to kinetic energy. Kinetic energy initial, since it's elastic, has to equal the final kinetic energy. So I have, let's see, 1/2 m1 v1 initial squared plus, and since the first object is stationary, once again its kinetic energy initially is going to be 0, equals 1/2 m1 times v1 final squared plus 1/2 times m2 v2 final squared. Quick inspection, we can multiply everything by 2 to get rid of the halves. That's not a problem. So the halves go away. And I end up with, let's see, well, m1 is 2 kilograms times 3.98 meters per second, but the whole thing's, that's squared, equals 2 times v1 final squared plus 7.1 times v2 final squared. That's going to give us, let's see, over there on the left is going to be it's going to be 31.7. I'm going to round more than you probably should just because of limited space and time here. Equals 2 v1 final squared plus 7.1 v2 final squared. And so now I have another equation that involves v1 and v2 final. This is my first equation. We'll bring it down here. So here we look at both equations. What I'm going to do is I'm going to solve this equation, the momentum one. Since it doesn't have any squareds in it, I'm going to solve this for, let's solve it for v2 final. And then plug whatever v2 final is equal to, that expression, in here for v2 final. So let's go ahead and do that. We're going to go 7.96, subtract the 2 v1 final from both sides. And we're going to divide everything by 7.1. So I'm going to have, let's see, 7.96 divided by 7.1. So I have 1.12 minus, let's see, 0.2 divided by 7.1 sorry, not 0.2, 2 divided by 7.1 is going to give me 0.28 V1 final. And since I divided this by 7.1, I'm going to have V2 final over there. And so all of this right here, since it's equal to V2 final, all of that is going to get plugged in here. And then the fun's going to begin. So let's use different colors to our advantage here. So we are going to have 31.7 equals 2 times V1 final squared plus 7.1 times 1.12 minus 0.28 V1 final squared. So I just took all of this that was equal to V2 final and plugged it into where V2 final used to be. So now I have to do some squaring. So off to the side or a little bit. So this is in a whole different color. I'm going to take care of this. I'm going to square this. So I'm going to have 1.12 minus 0.28 V1 final times itself. Using FOIL or whatever method you use to multiply these days, whatever the kids are using these days to multiply those out, let's see, we're going to have 1.12 squared. So that's going to be 1.254. That's going to be this times this. And then we'll do outsides. We'll do this times this. So that's going to be 1.12 times 0.28. This will be negative 0.3136 V1 final. You'll notice that when we do the insides, it's really the same thing. So another one of those, 0.313636. V1 final. And then lasts will be this times itself. So negative times negative will be positive. So 0.28 squared equals, so it's going to be plus 0.0784 V1 final squared. Which, combining the two middle terms here, is going to give us, let's see, 1.254 minus 0.3136 times 2. So 0.6272 V1 final plus 0.0784 V1 final squared. So all this is in green, right here, all this is this after I square. So I have the following. I have 31.7 equals 2 V1 final squared plus 7.1 times this stuff. 1.254 minus 0.6272 V1 final plus 0.0784 V1 final squared. And of course, now we got to take that 7.1 and distribute it. Multiply it times each of those three. So 31.7 equals 2 times V1 final squared plus, let's see, 7.1 times 1.254 equals 8.903 minus 7.1 times 0.6272, 4.453 V1 final, plus 7.1 times 0.0784 is 0.553 2.566 V1 final squared. There we go. Now, everything's got to get on one side, so we're going to subtract this from both sides, 31.7 from both sides. Now, the only thing it could combine with is the other constant here. So we're going to combine those. So we're going to have 0 on the left equals, we'll take our time cleaning this up, 2v1 final squared. Let's see, I need 8.903 minus 31.7 is negative 22.797 minus 4.453 V1 final plus 0.5566 V1 final squared. So let's clean this up a little bit. We're going to combine the two ones that are V1 final squareds. We can combine those. So that's going to be 0 equals 2.5566 V1 final squareds. There we go. Minus 4.453 V1 final minus 22.797. And I now finally have the quadratic formula that we mentioned in class. This is my A coefficient. This is my B coefficient. And this is my constant, my C. And the quadratic formula says, well, it's working right now. So the quadratic formula says V1 final is going to equal to negative B coefficient plus or minus the square root of the B coefficient squared minus 4 times A times C all over the entire thing, not just the square root, 2 times A. So we'll plug in what we know. V1 final is going to be the opposite of B. So that's going to end up being positive 4.453 plus or minus 4.453 squared minus 4 times A, which is 2.5566, times C, which is negative 22.797. All over 2 times 2.5566. All right, fun with numbers, ladies and gentlemen. So we're going to attack the, what they call the discriminant. We're going to clean up this mess. I usually work pretty deliberately, so I don't try to avoid mistakes if I can. 4.45. All right, so 4.453 squared. I got plus or minus the square root. Now I got 19.829 plus, and I know it's going to be plus because that's a negative, that's a positive, and that's a negative. So if I multiply negative times a positive, I'll have a negative. And then when I multiply that by another negative, it'll be positive. And it's going to be 4 times 2.5566 times 22.797. So that's going to be 233.13 all over 2 times 2.5566, which is going to be 5.1132. So then, cleaning up the inside. So I got 19.829 plus 233.13. Boom. Take the square root. So that's going to give me V1 final is equal to 4.453 plus or minus 15.905 over 5.1132. Now, let's see. gotta be careful here. V1 final after this collision. So V1, because if you notice, we're going to have a negative answer for V1 final, positive, and there are going to be two different numbers. Let's go back to our original problem. So, if the ball were to rebound off, so if it comes in, if ball 1 hits ball 2, which is stationary, so it comes in like this, it could bounce backwards, or it could hit and go forwards and be moving at a slower speed maybe. Tough to say. So we may need to look at both of these situations to see which one makes the most sense later on. So we'll have to look at both. V1 final could be, let's see, positive. So in order to get a positive answer, I'm going to do the 15.905 plus 4.453, get an answer, then divide it by 5.1132. So my one possibility is a positive velocity of 3.98. I'm not saying one of these might not make sense. We'll see. Or another possibility, this is an initial velocity though, isn't it? Okay, so I take it back. This is the initial velocity of 1, not the final, or is it? Yes, it is a final. So I take it back. Or the negative possibility would be 4.453 minus 15.905. Get an answer. And divide that by 5.1132. It should be negative 2.24 meters per second. Okay. Now let's go back to our original problem. It came in at 3.98. Alright, well then this seems to be, this to me doesn't make sense. Because after it hits, it's not going to still have the same velocity. So this is our beginning situation right here. This is a throwaway answer here. This is the answer I'm going to go with, and this tells me that it must rebound off of the other ball. So V1 final is going to be negative. It's going to be to the left. So V2 final, where do we go to find that? Well, we're just going to plug that in to, let's go find it. It's here somewhere. There it is. So we're going to take, let's use, take this guy, and we're going to clone it. And we're going to take it down here. Alright, so now to find V2 final, I'm going to plug in here. So I'm going to take this number. Let's see. Take this number for V1 final, plug her in here, and end up with, let's see, 1.12 minus 0.28 times negative 2.24 meters per second equals V2 final. And with a few pushes of the buttons, minus 0.28 times negative 2.24. I get a final velocity for V2, or ball 2, yeah, of 1.747 meters per second. And it's positive, so after the collision, ball 2 is going this way at 1.747 roughly meters per second. Ball 1 has rebounded this way at negative, he forgets already, 2.24 meters per second. Now the question is, am I even remotely correct? Moment of truth, on tape, as people walk out of my room. Alright, I think I'm pretty good. Negative, positive, that looks about right. This, I don't know what they're asking for. Find the magnitude and direction of the final velocity. It's completely inelastic. We'll get to that in a little bit. I wanted to focus on this. The other one you should be able to do already. All right, here endeth the lesson.